Unless you've been living under a rock, you'll know that
artificial neural networks
are the next big thing in computer chips. Why? Because the battery in your phone sucks and you hate waiting for that little annoying blue circle thingy on your laptop to clear. Don't know what
the artificial neural networks
are? Here's some science. This is John von Neumann. He invented the architecture that enabled the information age, but sadly it's now causing a problem. There's an inbuilt flaw that's pushing technologists towards neural networks. Yes, like the ones in your brain. That problem is right here, the von Neumann bottleneck. To explain it better, let me introduce my friend Bob. We need to find Bob in a crowd. Using von Neumann architecture, Bob's image is stored in the computer chip's memory, but in order to match Bob to his image, the chip has to search through every image stored in a linear manner, asking constantly, "Are you Bob?" in turn until it finds a match. This both uses a lot of power and is time consuming because the processor and memory are separate elements in the chip, and the bridge between them acts like a bottleneck. In a neural network, Bob's image isn't stored in a separate memory element. It's stored on one or more neurons, each with a small amount of processing power and a small amount of memory. So to recall Bob's image, all we need to do is broadcast "Where's Bob?" to all the neurons and we get an instant response. This is because neural networks are massively parallel instead of being linear. So, we need neural networks, but they won't be available till
1993. We designed the first chip together with IBM in 1993 as a partner.
But if IBM have been building neural network chips since 1993, why haven't they said anything?
And, in 2001 they decided to stop making it.
Oh, what then?
In 2007 the neuromem 1K, which is that chip.
The neuromem CM1K, 1024 artificial neurons. Holy, that's a neural network.
And we went on designing additional products, including the CogniSight, which is for industrial inspection. That's the inside of the CogniSight.
CogniSight industrial camera, powered by a neural network? No.
And we also designed for non-image recognition the NeuroStack, where you can see here packed in the NeuroCube, which is equivalent to 3.4 tera operation per second for 12 watts.
NeuroCube, 3.4 tera operations per second at 12 watts. I don't even know what the f that means. What I would like to know is why isn't it already in my phone?
Our expertise here, or what we like to do, is vision image processing, but that chip can be used for audio recognition, text recognition, DNA sequencing, you know. There were basically too many markets, and that's been our dilemma.
What's changed?
I found about the maker movement just to keep my kid busy.
Makers?
I realized we needed the help of these people because, like, I have expertise in image processing, but not in audio or in, you know, telecommunication and things like that.
And now we are designing this neuromorphic technology available to everybody.
Introducing the BrainCard.
It's a board which has a neuromem on it and which can be plugged into the Arduino environment, which is well known by the makers, very easy to use, and together with our trainability.
I forgot to mention that, didn't I? Yeah, you don't program this chip. You teach it.
The ability to train, I think the makers will be able to do very interesting things, especially in the vision field for robot guidance and UAV as well, or others.
If that didn't your mind, then he will. His name is Dr. Randall Kone, neuroscientist. We'll wait while you Google him.
You could use it for a variety of applications. You could build drones with it, you could use it to do stereoscopic vision on your robot, you could do it for pattern recognition and for word recognition, audio, voice recognition, and many other things that we probably even haven't thought of yet. The point is that it's an easy thing to use, it's not complicated to understand how it works, it's a very clean design. So it's extraordinarily easy in the future to upgrade this, to increase the number of neurons that are going to be on each chip, and to build systems that are very low power. They could be used in mobile applications, and to just take them out and experiment with them.
No, that's the problem. I always smile except on pictures. That's the key. You know, always on picture. I'm never smiling.